Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics. And this question belongs to paper 9709/43 for the session May June 24. Let's go through the question number 5 of this paper. Question number 5 says a van of masses 4500 kg is towing a trailer of mass 750 kg down a straight hill, inclined at an angle of theta to the horizontal, where sine theta is equal to 0.05. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are constant resistance forces of 2500 Newton on the van and 300 Newton on the trailer. It is given that the tension in the tow bar is 450 Newton. Find the acceleration of the trailer and the driving force of the van's engine. Well, we have understood the question. So first of all, we will have to draw the diagram. Let's draw the diagram. It may look like this. Yes, just over here I'm going to draw the diagram. So it says, suppose this is the horizontal line, just over here. No, not over here. This is the road. Okay, this is the road, and on this road it is, we should not forget that the van and trailer are sliding down, I mean moving down. Look at this, it is down a straight hill. Okay, so as it is moving down, so our diagram should not be like this. Our diagram will be as both of the van and trailer are coming down, so they will move down like this. Suppose this is the hill. Okay, in this hill the angle between the horizontal ground and the hill is theta. Okay, and this is the normal reaction acting on the particles, and this is weight acting downward. So yes, this is, and this is also theta, this is theta. So what are the van doing here? Suppose this is the van. Okay, van is moving down and it is towing. This is the trailer. Okay, trailer is being towed by the van. This is van, as well as this is the van, and this is the trailer. Well, that's all about the information. Now we are going to solve the solution stepwise. Yes, this is the scenario. Okay, so from this diagram, first of all we should know which concept is to be applied here for solving this question. We know that for finding acceleration and tension there are two values missing. What are these? Either two, acceleration, only acceleration is to be obtained, so only one equation is sufficient. Is it acceleration of the trailer and the driving force? No, one equation will not be sufficient for us. We'll have to form two simultaneous equation. And what is the concept we are going to apply here? The concept we are going to apply here is the most widely used concept of motion law of Newton. So what is the concept of the motion law of Newton? We know concept of the motion law of Newton is driving force. This is forward. First of all, this is about trailer, acceleration of the trailer. Look at the acceleration of the trailer. So we'll start with the trailer. For trailer, and the direction is it is sliding or moving down. Well, and the concept we are going to apply is driving force minus resistance force is equal to mass into acceleration. Well, now the driving force for the trailer, look at this. If we look at the trailer, the driving force is nothing but the tension. Okay, tension is the force which is acting on the trailer to move down, and at the same time there is another force which is causing drive the train. So this is also driving force. What is that? That is actually weight. So what is the formula for weight? We know weight is mg sine theta because angle is theta. Okay, these are the driving forces. And what is the resistance force? There is a constant frictional force. Let's see what is the constant frictional force on the trailer. It is written 300 Newton is the constant resistance force on the trailer. This one, 300 Newton. So it is 300 Newton. Well, then we will see is there any force acting on this or not. No, there is no other force. And the right side is mass into acceleration. Mass of the trailer is how much? It's 750. So 750 A. 750 A. 750 A. Well, so on the right, left side, what is it going to be? Tension is given. Look at this. Tension in the tow bar is 450. So we will write 450. And mass of the trailer is 750 kilo. So 750 into acceleration due to gravity is 10. Sin theta is also given. How much is the sin theta? Sin theta is 0.05. 0.05 minus 300 equal to 750 into acceleration. Well, now if we simplify, what is it going to be? 450 minus 300, that is 150. So 150 plus, if we multiply 0.05 by 10, it is going to be zero point 0.5. Zero point 0.5 means half of 750 is 375. 375, it will be divided by what? 750. 750. 750 equal to acceleration. Well, acceleration of the trailer. Hence, a final value of A is, let me use my calculator, 150 plus 375 over 750. So our acceleration is going to be point 0.7 meter per second. So that is what the answer to the first part. Then they have, this is not all about the answer, it is one of the answers. Okay, we can write here answer notation. Then what is the next part of the question? Next part of the question is, look, it is written here, driving force of the van's engine. So it's all about the van. We will write here for van. For, we can write over here, changing the ink of the stylus, for van. Let me see whether there is space on the right side also. Okay, let us continue from here. For van. For van. So van is also moving downward the hill. Let's see what are the driving force. The concept is driving force minus resistance force is equal to mass into acceleration. Well, now let's see what is the driving force for the van. If we look at the figure, this is the figure. Okay, van is moving downward with its own driving force. So as it is missing, we will write driving force. And is there any force causing it moving down? Let us see. Let us see. Look at this. This is the van. Okay, when van moves down the hill, then this weight is also causing it move down. So weight is also an external force which is contributing as driving force. So we'll have to add up weight plus weight. What is the formula for weight? We have already written here. Weight is mg sine theta. Mg sine theta. Now resistance force. So what is the resistance force acting on the van? Here is the van. This is van. So the resistance, only resistance force for the van is the tension. So let us write minus T minus T minus T equal to, and there is another frictional force, constant frictional force. Let's see, there is a constant frictional force of 2500 Newton on the van. So it is also to be subtracted, minus 25 minus 2500 equal to mass into acceleration. What is the mass of this van engine? The engine of the van has a mass of 4500 kg. So 4500 into A, it is going to be 4500 A. Okay, and for that I will have to write here, let me erase this A, it may be written just over here A. Well, so this is the step for the van's engine. Okay, well, after that what are we going to write? Or driving force is going to remain unchanged. Driving force, let me change the ink back. Okay, so it is driving force is to be obtained, it will remain unchanged, plus mass of the van's engine we have already used, it is 4500 into acceleration due to gravity is 10, and sine theta is, as usual, sine theta is 0.05 minus tension. We have already obtained the tension. Tension is already given. Tension is 450 Newton minus 2500 is the constant resistance force, means frictional force. 2500 equal to 45 4500, right side 4500 into acceleration. We have already obtained acceleration is 0.7. 0.7 is the acceleration. Well, now if we simplify this step, then it is going to be, well, on the left side driving force is missing, so let it remain unchanged. Driving force plus, if we multiply 0.05 by 10, it is going to 0.5. So 0.5 means half of 4500. So that is 2250. 2250 minus 450 minus 2500 equal to, if we multiply this, it is going to be 7 5s are 35, then 3 so 301. After that 2 zeros, so 1 0 will be over here because there is a decimal point before and 0. So this is 3150, the right side. So simply now we can write our driving force is equal to, now let us subtract this. This is positive is 2250, negative is 25004. So 2900, it is 700. So it is going to be 35 3150 plus from 2900, if 22 is subtracted, it is 700. 700. 700. Hence our driving force is going to be 3850 Newton. So that is the answer to the second part of this question. So that's all about the solution to question number A. I think you have understood. It's one of the very common, one of the most common and simplest questions in mechanics. That is applying the concept of the motion law of Newton, and as there are two values missing, so we had to form two simultaneous equations. Well, let's move on to the immediate next question. So the next question says, let's move on to the next question. On the next page. Yes, this is the question number B. On another occasion, the van and trailer ascend a straight hill inclined at an angle of alpha to the horizontal, where sine alpha is equal to 0.09. The driving force of the van's engine is now 9100 Newton, and the speed of the van at the bottom of the hill is 20 meter per second. The resistances to motion are unchanged. Find the acceleration of the van and the tension in the tow bar. So this is a little bit different from the previous diagram. Let us draw the diagram first of all. Yes, this will be the diagram. Now it is just moving upward. So suppose this is the hill. This is the hill and angle is theta. And this is normal reaction, weight moving downward, and angle is, here is theta. This is theta. Van is moving onward. Suppose this is the van and trailer is connected by tow bar. They are connected with each other. This is the trailer. Well, so the concept we are going to apply is exactly as same as the previous one. What will be our concept? The concept of the motion law of Newton. So first of all, let us write the for, this is find the acceleration of the van and the tension in the tow bar. So we can start with the van. Okay, so the concept, the same concept, that is driving force when for van. This is for van. For van, the concept is driving force minus resistance force equal to mass into acceleration. Let's see what is the force acting as driving force, and they are, the van is moving upward. Okay, moving upward. Well, so driving, what is the driving force? If we look at the diagram, look at this, driving force is nothing but the driving force of the engine. It is given. Look, driving force is, driving force of the van's engine is 9100 Newton. So it's given, we can use 9100 Newton. Then all the forces are now negative, I mean resistance motion. So first of all, we will have to write how much was the resistance motion to van's engine. They have told it is the resistance to, I mean frictional force was unchanged. frictional force. So let's see how much was the frictional force in the fundamental question. The frictional force was not on this page. Over here, the frictional force was, what was the frictional forces? 2500 Newton on the van and 300 Newton on the trailer. So 2500 and 300. So 2500 is the resistance force, or we can first write the 2500 minus 2500 Newton is the resistance force, and another resistance force is actually tension is causing the resistance to motion. Look at this. Here is tension is at the backward of the van. This is the tension force. So this force is backward in term of van. That's why this is a resistance motion. So tension, and is there any negative force or not? Then the most important one, the weight. This is the horizontal component of the force. So this is actually the horizontal x component of weight. So how to calculate this? This is also negative. Look, this is trying to move the van downward, whereas van is trying to move upward. So this is one of the resistance forces. So what will be the horizontal component of weight? It is, we know, mg minus mg sine theta equal to, right side is our mass into acceleration. How much was our mass? Our mass was 4500. We know that 4500 into acceleration. Okay, let it be a. And if we subtract 2500 from 9100, it is going to be 6600 minus tension minus mass of the van is 4500 kg into acceleration due to gravity is 10, and sine theta is given, it's a different angle. This is 0.09, sine alpha is 0.09. So 0.09 is equal to 4500A. Okay, 4500A. Let me write 500A. Well, after that, as there are two values missing, note acceleration as well as tension, so there must be two simultaneous equation. So the for first equation, let us isolate t. So 6600, and here can we do calculation here? 4500, that is 10 point 10 into 0.09, that is 0.9. 0.9 into 45 is going to be 6600 minus 4500 into 0.9 equal to 4500A. Sorry, minus 4500A. It is going to be minus 4500A, and we are transposing t to the right side. It is t. So this may be equation number 1. This let us leave this as equation number 1. Okay, so for this was the equation found for the forces, net forces on van. Now for we will calculate for trailer. For trailer, we are going to say apply the same concept. For trailer, let me see whether I can write it downward or not. Space is not sufficient, so don't start writing over here. We will write just on the left side. Yes, here we can start for forward for the trailer, for trailer, trailer, for trailer, driving force minus, let us show the direction, because direction matters in force. Force is a vector term, it is also moving upward. So driving force minus resistance force is equal to mass into acceleration. Well, so driving force for the trailer is nothing. Look at this. If we look at the trailer, trailer is this. This is the trailer. It is being pulled upward, nothing by, nothing but the, but by the van. So van is actually this tension. This tension is the only driving force or forward force for trailer. So it is nothing but T is the driving force. T is the driving force, and the frictional force is unchanged. We have used the frictional force. Frictional force has been given on the previous page. Here frictional force was, I think it was 300. Yes, this is the frictional force on the trailer. So it is 300 minus 300 minus 300 minus 300. Then we will see whether there is any other force acting as resistance or not. Yes, weight is also the horizontal. As we are calculating this is our, you know, road or hill, whatever. So this force, horizontal force, this is not horizontal in term of the triangle, this, because this is 90 degree. If this is 90 degrees, so this is our vertical force in terms of this triangle. So this force is also acting as resistance force. So weight is causing resistance, that's why we will have to write mg sine theta or alpha, whatever you tell. Alpha, there is no other force acting on this as resistance, equal to mass into acceleration. Mass is 750 and acceleration is to be obtained 750 a. If we isolate our t, no, let's write one more step. 300 minus mass is 750 into acceleration due to gravity is 10 and sine alpha is given 0.9, 0.09, 0.09 equal to 750 a. Well, so if we isolate our t, then t is equal to 300 and 750. It is going to be zero point 0.9 into, okay, 300 plus 3. First of all, we can write the already right side. That is 750a, 750a plus 300 plus 300 plus 300 plus 7500, 750 into zero point 0.9 into zero point 0.9. So these are the all about the equation number 2. This is equation number 2. Now we will write from equation 1 and 2. We will write here from equation 1 and 2. From equation, solving the equation simultaneously, from equation 1 and 2, solving the equation simultaneously, we will get the values, missing values. It is 2. Well, so equation 1 was 6600. So let us write 6600. Let me zoom it out. Equation 1 was 6600 minus 4500, 6600 minus 4500 into point 0.9 into point 0.9. Then what is next? Minus 4500a. 4500a. Will it be 4500? Yes, 4500a. Then if why should it be 4500? 45, then there will be one more zero more, because if we multiply, oh no, it's all right. Okay, so 4500a minus 4500a minus 4500a. Now let's write the equation 2. Equation 2 is this one: 750a 750a plus 300 plus 750 into plus 300 plus 300 plus 750 into zero point 0.9. So this is what the step, that means the two equations, equation 1 and 2. This was equation 1, this was equation 1, and this is equation 2. So we have written both of the equations on each on two sides of the new equation. Now let us do calculation. 6600, from these if we um, let us multiply 4500 into zero point 0.9. 4500 into zero point 0.9, then 4500a. Okay, one after the other. Look at this. On the left side 4500a, on the right side 750a. So it is going to be negative 5250a. Okay, then rest of them should be on the right side, because we require a to be isolated. Here what is given there, it is 300 plus 750 into zero point 0.9, then minus 6600 plus 4500 into 45 plus 4500 into 4500 into zero point 0.9. So that's all about our terms. Well, then what is it going to be? Negative, if we isolate a, let's isolate a is equal to, then 5250. If we dissolve the symbol, all of the symbols will be changed. So first negative one is going to be positive 6600, then negative not 6600, we can write it 6300, because after doing subtraction, if 300 is subtracted from 6600, it is 6300. Then minus, here 750 into zero point 0.9, here 4500. So 4500 and 750, it is 5250. 5250 into zero point 0.9 into zero point 0.9. Hence our acceleration is going to be, our acceleration is going to be, hence our acceleration is going to be, let me use my calculator, 6300 minus 5250 into zero point 0.9 over 5250 over 5250, then it is zero point 0.3 0.3 meter per second. 0.3 meter per second. Let me write this S over here. 0.3 meter per second. This is what the answer to one of the parts. This is acceleration. They didn't tell only to find acceleration. Now we require to find, they have told us, look at the question. The question has told acceleration as well as tension in the tow bar. Acceleration has been obtained, now tension to be obtained. So we will write our tension is equal to what? This is what tension is equal to. So simply we can write hence tension is equal to, hence, let me change the ink. The color of the ink may be this. Hence our tension is equal to, tension is what? From any of the equation we can pick it up. This is 750. So 750 into acceleration is zero point 0.3 we have just obtained, plus 300 plus 300 plus 750 into plus 750 into zero point 0.9, 750 into zero point 0.9. Hence our acceleration, I mean tension is going to be tension, hence our tension is going to be hence symbol is not necessary here, equal to, tension is going to be what? 750 into zero point 0.3 plus 300 plus 750 into zero point 0.9 equal to 1200. So our tension in the string or tow bar is 1200 Newton. This is the final part of the answer. So these are the two answers. One answer was acceleration, which was zero point 0.3 meter per second, and tension force acting in the tow bar is 1200 Newton. So that's all about this solution, the solution to question number A of this part, I mean first part of this question. Simply we have formed two simultaneous equations because two values are to be obtained, acceleration as well as tension. Okay, then stepwise we have formed two equations and solved them simultaneously. So that's all about the whole of this solution. Let's move on to question number, the final question of this part. Find the speed of the van when it has traveled a distance of 375 meter up the hill. So first of all, we'll have to pick up the concept. The concept is, the same concept can be applied here for finding this. You know, velocity, look at this. Whenever velocity is asked, we should know whether one of the velocities are given or not. Yes, one of the velocity is given. It is 20 meter per second. So one of the velocity is given, then the final velocity is to be obtained. So simply, and acceleration is also in our hand. So acceleration, velocity, and the distance, I mean displacement, is also given. So we can easily apply the simple concept of v square minus v square. The formula of v square. V square is equal to what? Let us write v square is equal to v square. V square is equal to u square plus 2as. Okay. Hence our final velocity v is equal to, v is going to be, initial velocity u was just 20 we have seen. Let us see once again. It was initial velocity is 20. So 20 square, 20 square, it is square root over 20 square, 20 square plus 2 into acceleration, which is zero point 0.3 we have just obtained. Acceleration was 0.3 and displacement was 375 meter. Hence final velocity is, at the top of the hill, the final velocity is going to be, okay, 400, square root of 400 plus 2 into zero point 0.3 into 375 is equal to 25 meter per second. Okay, 25 meter per second is the velocity at the top of the hill, and that is the answer to this question. Well, that's all about this solution, and I tried to explain as much as possible on my part, and I think you have understood the fact and you learned how to solve such questions. So, thank you all for being with me. Inshallah, in the next video, we will solve some other questions. And let me show the previous solution again. And this is what the previous solution is. And the latest one is this. This one is the latest one. So, fi amanillah.